you are watching this, then it means that everything has occurred as I expected. The world has dramatically changed. It all started in 2021. Modern breakthroughs in quantum technologies open up the prospects for creating powerful quantum computers that will completely turn over the existing information paradigms. The fields of cryptography and information protection are no exceptions. Customers will no longer view existing protocols for exchanging secret information and encryption methods as reliable. A novel crypto system was created to guarantee the secure transfer of classified information to the assigned recipient for patching the breach. The essence of the novel approach is that although the transfer of the secret key from the sender, Bob, to the recipient, Alice, can be intercepted. By smart and technically equipped hacker Eve. Bob and Alice can still make their information transfer decipherable. The quantum states that encode information enable control over the degree of Eve's intrusion and estimate the signal leakage limit at which the transmitted message's security is not compromised. Therefore, these are fundamental quantum laws that govern quantum states, which ensure the full protection of the information's transmission based on the novel protocol. The new crypto system will come in handy for a young scientist, Bob, engaged in a top-secret development of a vaccine against the new virus. After building the cryptographic line, but before putting it into operation, the user carries out specific procedures to prepare the line for secure data transmission. First and foremost, the user employs an optical reflectometer to measure the loss of signal along the entire line's length. To that end, first the reflectometer sends laser pulses through the line. The pulses scatter in various uneven parts of the optical fiber, such as joints. Next, the reflected impulses go back to the reflectometer. Learning the delay times, optical phases, and signal amplitudes, the user establishes the level of losses at one point or another point of the line. The resulting reflectogram describes the state of each meter of the line, allowing one to identify the places of the joints and to record any intrusion into the line. To make the message transmission an unreadable secret, one uses a random number generator to produce the secret key to encrypt the message. It is continuously broadcast to the recipient to make it impossible even to establish the fact of secret data transmission beginning. The used random number generator works directly utilizing quantum processes. The quantumness guarantees that the generated series of numbers are indeed true random sequences. The key is transmitted using a device called Mach-Zehnder interferometer, which converts the bits of the key into optical signals and sends them through a fiber optic line. Even if the line suffers from being tapped by a cryptanalyst, the secure transmission of the secret key over the quantum channel is highly feasible. The idea is to make it impossible for the interloper to distinguish zeros from ones in the binary sequence. Security is achieved by reducing the difference between the signals corresponding to zeros and ones in the transmitted 0 and 1 number sequence. Eve would attempt to steal a low-intensity signal while trying to stay unnoticed. Transmitting the information by the low-power non-classical radiation diminishes the harm of her intrusion. The fewer photons Eve intercepts, the less likely she would be able to distinguish 0 from 1. The probability of discriminating decreases exponentially with the decreasing intercepted signal fraction, making Eve's decrypting even one bit of the key almost impossible. Since protection of the transmission from eavesdropping is provided by deteriorating the distinguishability of the signal's logical states, the signal's distortions are an inevitable price to pay for keeping the key secret. Eve's intrusion also causes errors, and the stronger the intrusion, the more distortions the key will suffer. On the other hand, after exchanging a small part of the distributed key over an open channel, Bob and Alice can analyze the error rate and calculate how much signal Eve had intercepted. If the error rate exceeds a predetermined threshold, the transmission is interrupted to execute specific measures, eliminating Eve's intrusion. In order to eliminate distortions during the secret key transfer, Alice tells Bob the bits that she could not distinguish. These bits are then removed from the key, and the key shrinks. Quantum networks are not perfect, so some errors do happen. Therefore, Bob and Alice use a correction algorithm that consistently corrects all errors. As a result, Bob and Alice receive the same key. Since there was an intrusion into the transfer, and hence Eve could have partly intercepted the secret data, Bob and Alice strengthen the key by running it through a hash algorithm. As a result, the key changes completely, both in meaning and length, and the information that Eve might have gotten at her disposal becomes irrelevant. To encrypt the original message, the key shared by Bob and Alice is added bitwise by Bob to the binary representation of the message. This encryption method is thoroughly reliable and allows for the obtained ciphertext to be safely transmitted over an open channel. Thanks to the developed crypto system, Bob managed to transfer the secret data to Alice and at the same time protect his data from Eve. A new era of digital security has arrived, and we have no place in it.